Ready to dive into code? Okay, so I've inserted some line numbers. First, 4 and 5, we introduced the two libraries. You know NumPy, but now we're adding a scikit-learn class of functions. And we want, from this whole library, we just want to pull down the k-means method. And I'm trying to be good now. I'm putting all my constants in capitals. This is the video you're going to give it. It doesn't actually need the video. I think that was left over from, yeah, sorry, that was left over from other code. But it does need to know the feature file you're using. This is the file. It has to have, in each row, it has the object and it has the features and a place to put the cluster once it figures it out. Okay. And now it's going to, because it's taking your file, which has an object number, and it's going to replace that object number with the cluster, I'm actually going to save it as a separate file so I can keep those two files separate. I have my detect file, which just has the object ID, but now I'm going to replace the object ID with my cluster ID, and I'm going to save that as a new file. Okay? And so I have to give that a name. And here's the important, how many clusters is it? And that's the number I was changing to show you. I think Madhu suggested 50, and we got very good fit. Okay, so now this is a technique I use. You know, each row of the object file has many columns. And instead of using numbers to address them, which is really confusing in the code, it's always good to use labels. So what I've done is I've defined labels. I've labeled every column. So in my code, I can refer to it by name, by label, instead of by number. So as you probably remember, the first column is frame. The second is ID, the object ID to start with. That's the one we're going to replace with the cluster ID. And you notice it's the same column. So when I read the feature file, I call it ID. But when I save it as a cluster file, I'm now changing the name to cluster. But it's pointing to the same column. And then we got our location, and then finally our features. That's in one row. Okay? And this is the header. When you save files, it gives you the option in NumPy of saving a header. Always good to put a header in, because even though the program ignores it, if you open it in Excel, those labels will carry over. I always use a smaller resolution so it won't take up my whole screen. And now I've defined a function. I usually try and make functions because it makes the code clearer. So here's the clustering algorithm, and you can see how powerful scikit-learn is. This whole process is just these lines of code. You basically give it the features. You tell it how many clusters you want. This is basically creating an object it's creating a method. And this is one operation you can do, which is you take the method and you told it how many clusters you want. You give it the features, and it's going to return, it's going to give you this K, which you can then interrogate. I tell it to fit, based on the data, fit it to the number of clusters, and it's going to predict. For every object, it's going to predict what cluster it belongs to. It'll also tell you the centers of where they are in the feature space. We don't use that here, but it's useful for seeing how far off the center something is. If you want to see how strong of a member it is. It'll calculate the inertia for you. And mind you, the inertia is a huge number. So what I do is I divide it by 1,000,000, and then I take the integer. That's why we saw it reading 0. It probably was some fraction, but the number it's just too hard to read when it has that many digits. So I just make it human readable. And then I present the value here, and I also show how many iterations it went through. And then I return the predictions is what we're mostly interested in. We were just looking at this part. This is the function. So now this is the main program. So we have to load our feature file. I just tell you that it's loaded, and I put the shape, and the shape tells me the dimensions and how many elements, so I can tell how many objects I have. Now this is where your data slicing is important. So the feature file, remember, it has all this information, and what we want to give the k-means algorithm, we just want to give it the features. You don't want to give it frame number and location, because it'll think those are features and it'll get really confused. So how do I peel off just the features? Well, this is where labels come in really handy. The features start at area. So I'm telling it the first element of the first dimension of the array is all the rows. So we want all the objects. So that's why I put the colon. So that's saying, give me all the rows, but what columns do I want? If I just put colon in here, it'll give me all the columns too. We only want the features. So how do we extract just the features? We split the array. We say, give me columns starting with area, that's one. And we want to go all the way to solidity. But since it's the last column, I can just put a blank there. And Python knows if there's a blank, that means go to the end. And for another splitting, just a comment about splitting, if I didn't want solidity, if I put a -1 as the last entry, that would say one less. But anyway, so this is basically saying, give me all the features from area to the very end. So it's taking these 4 features. Okay, so now I made a feature set. And I give that to the do cluster. That's what xt is. We just did, we created at 33, we created our feature set. On 36, we gave it to the do cluster function, and it returned k, which is the handle to the object, which it doesn't look like I'm using. It gives you the centers, which, as I was mentioning, you could measure each object, how far it is away from the center, because that's kind of a confidence measure. The further you are from the center, the more different you are from the average. But we're not doing that here either. The thing we're most interested in here is the predictions, which is basically a list, and it's the same number of objects. So that's why this statement works here. I'll explain in a second. I'm basically telling it, take all your predictions. That's why I have the colon in there. Take all your predictions. And this one is all the rows of the object, but it's only one column. So you have to make sure the sizes of the right and left are equal. So this is saying, take my feature file, take all of the rows. So the amount of rows here has to agree with this, which it does because it was created from the same file. But this one's saying just the row named cluster, which happens to also be the one that was ID. So I'm going to replace the whatever's in the ID with, now I'm going to replace it with the predict. So this is saying, for all the rows of the feature file, I want you to take the cluster column and put in the values of the predict. Okay, so this basically took the clusters and put it in place of where the ID was. And now, since I messed up or I altered feature file, I don't want to save it as the same thing, because I want to be clear that the detect file only has object IDs, which is, bouncing all over the place. Now I want to create something I call a cluster file. And so I called it cluster file, and I saved this file. It's the feature file, but remember I changed the ID to cluster now. I save it as a new name, and I used a new header that I defined up here, a cluster header. And what does it have? Basically has everything the feature file did, except instead of object ID, I replaced it with the word cluster, because that's what it is now. And I save it.